want to kind of look at some bearings problem. I'm actually going to start with one that was not assigned, number 34 in the book, just so you kind of get an understanding of what's going on with bearings. Okay, so with bearings, it's you're measuring an acute angle. Let me draw a little. This is north, south, east, and west. Okay, with the bearing, you're measuring the acute angle of a path or line of sight made with a fixed north-south line. So I've drawn a like north-south line, and we can actually put this on anything that we're doing. And for instance, in 34, it says that you've got an airplane flying 600 miles an hour, and it has a bearing of 52 degrees. Well, how you measure that bearing of 52 degrees, if you look, let's see, where was that in your book? If you look on page 333, it says that in air navigation, bearings are measured in degrees clockwise from north. So clockwise is going this way. So if I've got a bearing of 52 degrees, it means that I'm making an acute angle of 52 degrees from the north. So this is the direction the plane is flying here. Okay? Now, if it flies for 600, if it's flying at 600 miles per hour and it flies for 1.5 hours, remember distance is just equal to rate times the time. So my distance is what I'm trying to find. My rate is 600 miles per hour. My number of hours is 1.5, so we'll just say 1.5. It would have flown 900 miles, and let's see how they want the answer. It says how far north and how far east has the plane traveled from its point of departure. So let's see. Let's think about that with a right triangle. Maybe let's draw a little right triangle here. If this is a 52-degree angle right here, measured from the north. Actually, that's not quite right. Is it measured from the north? So it's measured from 52 degrees from the north. That would be right. It's like the plane, and to kind of make this make sense, because I know this confuses me a lot of times too. The plane's here. Why didn't it draw? I'm trying to draw a little blue dot. Oh, it just did select. Okay. Plane started here and it went north, a bearing of 52 degrees. You measure it from the north. So it's going, if you do the 52 degrees from the north, it's actually going this way, okay, which is the direction the green line's going. So if I want to know if it started here, if on my right triangle, if I wanted to know the north and how much east, I'm basically trying to find the sides of some right triangles, of this right triangle. And I'm going to need my calculator for that. And I'm probably not even going to solve this out to get a number here. I'm just going to, because I don't even have my calculator with me, I'm at home working. And my calculator at home has quit working, so I'll just write it in terms of trig functions. Since we have the hypotenuse here, and I have an angle here, I could say, well, what if I wanted to find the north component? Let's say we'll call it N for north. That would be if you think about it, here's your angle, that would be the adjacent side and the hypotenuse. So I could say cosine of 52 degrees is equal to N over 900, and I could actually solve this. I could make a proportion out of it, and I could say 1 times N is N, and this is just for the north component, and then it would be 900 times cosine 52 degrees would be how many miles it's gone north from where it started. Now, if I want to find the east component, I'll do that in like a purple color just to kind of distinguish the two workings here. If I want to do east, I want to use the thing I already knew from the problem, just because you want to use known information as much as possible. It just leaves less room for error. At least if I mess one up, I don't want it to keep messing up more problems. So if I look at my 52 degrees and my east is my opposite side, my 900 is my hypotenuse, so that would be sine. I could say sine of 52 degrees is equal to, the opposite is east, and the hypotenuse is 900. And if I make this a proportion by putting sine 52 over 1 and cross multiplying, 1 times E is E. The east component is going to be 900 sine 52 degrees. Make sure when you're doing this work, your calculator is in degrees for these computations, since they're actually giving you your information in degrees. So if you want to have your answer match up with the answer key, you'd have to have in degrees in your calculator. Let's look at number 35. It's a surveying question, and again, it's going to involve bearings. A surveyor wants to find the distance across a pond. Basically, I think he's trying to measure from A to B there. I'll highlight it in orange just so we know that's what he's trying to find, is this distance right here. It says the bearing from A to B is 32 degrees, north 32 degrees west, okay? So north 32 degrees west.